Okay, from this science research have to keep continuing question and for the research. You see these two groups. One is the temperature group, and another dryness group. This grouping is conducted by the professional, statistic program, not by hands, not subjectively, but objectively. So you see this T group, if T group no data, if the annual mean temperature is about 16 degrees C, there's no data point. These data points will be automatically will coming to the dryness control group. Yeah. So you see there's a temperature threshold value 16 degrees C. Above 16 degrees C, they will come to the dryness control group. Temperature does not matter because warm enough. Water does matter. You give me water, I will do more photosynthesis. Yeah. So 16 degrees C is threshold temperature. So next idea came up from me. Where is the 16 degrees C latitude? Yeah, we have climate data. Yeah, we have climate data. So from climate data for annual temperature, we should know where is the 16 degrees C, where is below 16 degrees C, where is above 16 degrees C for in 1950s, for 1951, for the 1952 until now. Then we find this threshold temperature 16 degrees C latitude belt. This belt stay somewhere stable or is moving. If it is moving, it's moving to the north or is moving to the south. That would be interesting, right? So where is the 16 degrees C boundary? Yeah, so we will find out from the data. Data are available. At that time, I asked my PhD students, Shu Wei, to do this. Yeah. So we use data, just climate data, since 1948 to the 2014, I think. Yeah. So for every year we have the data. You see the green part. If temperature below 16 degrees C, for this time period, we use the green color. Yeah, that area below 16 degrees C. For the yellow part, the temperature is above 16 degrees C. For the purple part, temperature from below 16 degrees C become above 16 degrees C. Yeah, the purple area from cold become warmer. The purple area is a boundary of 16 degrees C shifting. Yeah, very interesting. So then we make some data average for temperature. You see the land from the North Pole to the South Pole land. Every area has a temperature. We can sum them up, make them average, so we can see the land average temperature. Here is a red curve. Yeah, you see, since 1976, even this curve up, down, up, down, up, down, but yeah, let's keep going up. That's warming. Yeah. Another is for the warm part. Yeah, above 16 degrees C, the area. Yeah. So that area, yeah, is become larger and larger in overall. Yeah, but also is up down, up down, up down. But the overall trend keep going up. Yeah. This warm area expansion has a good correlation with land average temperature. You see the X is land average temperature. Y is a percentage of drainage control area. Yeah, this has robust correlation. R squared is equal 0.9. Yeah. So global is warming, the warm part expanding, yeah, become larger and larger. This means the dryness control area is increasing with land warming. Yeah, how these phenomena link to the El Nino and La Nina? We know in the past which year is El Nino year, which year is La Nina year. Yeah, the red arrow indicates El Nino year. Yeah, you see the El Nino year. Most of them is consistent with temperature peak. Not all. 70% of land warmer is consistent with El Nino year. Right? Yeah. Okay, this blue arrow and the curve in the vertical are La Nina year. Yeah. Not every La Nina year is in the lowest temperature, right? Yeah. But 80% of La Nina year is consistent with land cooler. Yeah, that's interesting. This is for the whole land. This is for the whole land. Yeah, the whole land, you see the temperature is going up. The temperature is warming. Yeah. So another index we call the draft index. It is PDSI. Yeah. This stands for Palmer Draft Severity Index, PDSI. Yeah. PDSI, if PDSI is negative, that means dry. More negative, more dry. Yeah. The whole land PDSI is going down, is going to the negative. That means land, the whole land is warming. The whole land is drying. Land is warming, land is drying. This is for the whole land. How about warm part? How about cold part? How about shifted part? Purple area. The purple area is going, PDSI is going to the negative so quickly. That means the purple area is drying faster. Yeah, that's a problem. How about this cold part? Cold part is not drying. Yeah, it's a little bit of wetting, but not much significant. Yeah, for the cold part. How about this warm part? This warm part you see that the significance is going to become negative and negative, become drying and drying. Yeah, you see this warm part is half of land and become bigger and bigger with warming climate. Right? Yeah, that's a big problem. What is the problem? Yeah, you see this over half of land area is drying. Drying, that means dryness is become larger and larger, going up. If it is going up, will reduce CO2 transfer from the atmosphere to this vegetation in this area. Yeah, that means less CO2 transfer from atmosphere to the biosphere. Will keep more CO2 in the atmosphere, will accelerate global warming. More warming, more drying. That is positive feedback. Yeah. This positive feedback is not small things. This is more than half of land participating this positive feedback. That's a big issue, big problem. Nobody knows this. Yeah. And we can also think something about cold part, warm part, how this link to the La Nina, El Nino. Yeah. For the cold part, you see El Nino year, 50% El Nino year is cooler and wetter. 50%, 70% La Nina year are warmer, and 40% of La Nina year are drier. Yeah, has some correlation. Yeah. So this El Nino La Nina phenomenon is teleconnection. Yeah. So how about the warm part? Yeah. This warm part. Yeah. 90% El Nino year are drier. 70% La Nina year wetter. Yeah. El Nino dry. La Nina wet for this warm part. However, there's no correlation between this El Nino and La Nina with temperature. How about you? If here you stop? No. You do research have to continue to find possible answer. Yeah. We are explore the mystery in the world. The mystery between the biosphere and the atmosphere. Yeah. What did I do? I make assumption. There is a 1 year lag. Wow. There is a outstanding correlation. If you assume there is a 1 year lag, 90% of El Nino year are warmer, 80% La Nina year cooler. Why? Can you? This is a burning question. Why there is a 1 year lag? I'm thinking. So you see, net radiation is available energy on the surface. Net radiation is the sum of sensible heat and latent heat. Sensible heat is used to warm air, temperature going up. Latent heat not warm the air, but is used to evaporate water from the soil, from the plants. Okay? 90% in El Nino year, 90% El Nino year are drier. That means not much precipitation. Most of net radiation is used to warm up the air. So 90% of warmer. Yeah. So for the La Nina year, 70% La Nina year are wetter. Yeah. Wetter, more precipitation. Soil has more water. This water evaporates into energy. That energy is latent heat. Net radiation, most net radiation is used to evaporate the water from the soil, transpiration in the water from the plants. Less net radiation is used to heating the air. So 80% are cooler. Yeah, that makes sense. However, why there's a 1 year lag? Because it is the warm part, not the small part, not New York, not the United States. This is more than half of the land. So this reach, this equilibrium need time. This time is about 1 year. So there's a 1 year lag. But I'm not sure. This still is an open question. You can do some research to verify, to test this answer is right or no. Yeah. So here, for the purple area is is uh, is is drying fast. Yeah, the vegetation shrub. Yeah, most located in the Mediterranean area. So there's some satellite data showing this vegetation in the Mediterranean is going down. This land cover is reducing, yeah, because dry. So we think something. The picture is about a little bit big Hartley cell. You know the Hartley cell. Hartley cell at equator side, this area is going up. So there's condensation, there's raining, then it's wet, there's tropical rainforest. In the north side, yeah, that area is sinking, and sinking is dry. That's because of the dry zone. The dry zone causes a lot of desert. Yeah, Sahara Desert is located on this sinking side. This sinking side is a dry zone. However, a few studies have clarified with global warming, this Hartley cell become bigger and bigger. That means sinking side is shifting to the north. This dry zone is shifting to the north. This dry zone coincided with our 60 degrees latitude. From our study, this 16 degrees latitude, shifting latitude, is also shifting to the north. Yeah, you see this consistent between this dry zone and 16 degrees latitude. Both is shifting to the north because both are caused by global warming. Yeah, so is still there are a lot of open question. Yeah, based on this research. So you can read yourself. You can do yourself.